Hello, students. We are checking out some questions out of 13.1 and from the homework. And so first one is number 13. So let's take a look at question 13. Jump over there, number 13. Following as a circle's radius is 2 centimeters, the diameters of the two semicircle regions are also 2 centimeters long. Compute the length of the curve that separates the white and the shaded regions. So when you're looking at something like this, what you want to think of is, okay, this piece right here is half of the smaller circle's circumference, right? It goes halfway around that small circle. And then this piece up here also goes halfway around that smaller circle. So if you're computing the length of the curve that separates the shaded and the white, the idea, or at least a good idea, is going to be to think of saying, well, I need this piece right here, which is half of the smaller circle's circumference, and then the other piece right here, which is another half of the circumference, which means you really just need the circumference for the smaller circle. And remember, the smaller circle has a diameter equals 2 centimeters, but you need C equals 2 pi r. And I'll put the r in parentheses so it makes it a little bit easier to see. C equals 2 times pi times r. And that's how you can get there. All right, let's check in with the next question. And number 24. Let's take a look at 24. Ooh, next page. Give the greatest possible error for each of the following measures. Okay. So what you want to look at with greatest possible error is you need to think, if someone wrote down 136 meters, we have to be looking at that and saying, well, it looks like they were measuring to the nearest meter. So that means the smallest it could have been would have been 135.5 meters, right? That would have been like the low end that would have rounded up, right? And the high end would have been 136.5 meters. And what I mean by that is that's like it couldn't be that number, or it would have been a different. So it's like right up to it, which is basically this difference. So the greatest possible error, the amount of error from that number, would be 0.5 meters. Now, the same is going to be true for the rest of them. You just find the decimal location that they had. So this one is a 0.5. So again, what I said in class, and I think it might be helpful, is to think of this as 3.50. So think of it as 50 and think of like, well, what would have gotten me to 50? And you can say, oh, well, I could have gone down as low as 45. I could have gone up as high as 55. And so that tells you that you'd be at 0.05 feet would be your greatest possible error when you report those. Okay. And notice the error is not the total amount, like from left to right. It's just the total amount of error. You can only have error really in one direction when you make that measurement. All right, let's jump to some of the MCs. MC number 4. Okay, let's take a look. Here we go. Two concentric circles have a common center. The radius of the larger circle is twice that of the smaller circle. The radii intersect at A and B. What is the ratio of the length of the arc to the length of the arc of AB? All right, well, you can think of this because the radius is twice as much. You could think of this as like you could put some numbers in if you wanted to. But let's just say that the inside circle had a radius of 1 and the outside circle had a radius of 2. Okay. So then as you look at this, then the portion of the circle would be the fraction, right? So the whole circumference is 2 times pi times r. All right, for the smaller circle, but you're taking a portion of it based on this angle, the angle right here, AOB. So when you do that, what you could say is the measurement of that angle. And again, if you want to, you could just say 60 degrees. So put 60 over 360. And in your mind, what you're saying is this is a part of the circle. The sector This arc length right here, this piece is not the whole circle. And it's whatever angle it is divided by 360. Now I put in 60, but honestly, you could have put in any variable even, because the angle is going to be the same for both of these, right? COD is the same as AOB. And then you'd multiply by this component because you're taking a fraction of it. And I think what you'd get to see is a really nice relationship. I'm not going to give it to you, but that's how you can set it up. And again, like I said, you don't need to label this with a number. You could just call it angle X. So say that it's X over 360, and then it's completely fine. And you can still find the ratio of those two. And the reason for that is when you take the ratio, you'll have an X on top, you'll have an X on the bottom, and the X's will cancel out. So it doesn't matter what the angle is at the end of the day. Okay, so there's question 4. There's a push. Number 9. Let's take a look at number 9. And a tennis ball, flat bottom, contains 3 of the students. The circumference of the top of the can is longer than the height of the can. Student wants to know how the fact can be explained without performing any measurements. This is exactly what I had you do in class. So in class, I had you create, remember, you did like a long piece, which we called the circumference, and then you had like a shorter piece, right? And that shorter piece was the diameter, and you measured it from an actual circle. So when you think about that, let me ask you this: how many diameters were in the circumference? And then think about, draw out, if you need to, what this would look like, because you're going to have, just draw it as a 2-dimensional, right? And here's a hint: it's going to look something like this piece over here. If you had 3 of those balls, it's going to look something like this, 3 tennis balls, right? Well, how far is this length right here? Right? Right? Here's one diameter. Here's another diameter. You can go on. So how does that compare to the circumference, like what we did in class? So that class activity was really designed to help you with this specific question. So take a look back at your notes if you need to for that one. Number 11. A student imagines a wire stretched around the earth. That looks good. He says if the wire is cut, its length is increased by 20 meters and it's re-stretched around the earth, then the tallest person would walk under it. Okay, that seems sketchy, right? Do you agree with her? Why or why not? So you have a shape like this, a wire that goes around the earth. So Google the radius of the earth, if you will, okay, and use that for your radius. I know they didn't give it to you here, but you can look it up. Okay. And then they're going to do another one of these, right? Let's see if I can do the circle around a circle, right? It's going to look something like that, where you have a circle that is kind of around that one. So like if I was doing this problem, I would probably first thing I would do is I would use my information to find the circumference of the inner circle, which is the earth. Then add 20 meters to that, right? Then go back and use that, use it algebraically, because you know your formula is C equals 2 pi r. So now that you have the circumference, which has been added by 20, so increased by 20, you have that. So that goes right here in the circumference equation. And pi, use the pi button on your calculator. Do not use 3.14, use the pi button. And then you can solve for the new radius. And once you have the new radius, you can compare what's the radius of the original with the radius of the new. And you can see, is it big enough that someone could walk underneath it? You might disagree, but that's why we do the math. All right. And number 12. Let's see here. Yeah, so if you're looking for a way to kind of explain this, I'm going to ask you to not do the computations. I know it's very, very hard, but not do the computations. Create the computation you would use to find this red length, which is like a half circumference, right? Then don't do the number. Don't turn it into a number though. Leave it as a like a 2 times pi times something, okay? And then this one over here, do the same with the green. Then you're going to add those together. And I want you to go back to Math 105 and use your algebraic skills to see if you can't factor something out and determine if these are always the same or if maybe they are never the same. All right, there's some nudges for you. Hope that gets you going in the right direction. All right, off you go.